welcome to this ParaView tutorial. My name is Diletta and today we will be using ParaView to display a very high number of particles interacting one with each other, and we will see their behavior in time. So we will animate a very high number of TXT files, and we will see the particles moving through time. So first of all, if you have not done so, edit and reset your session so that as to clear everything you have. In this case, you see that we don't have anything, so we will not be needing this. And let's import our files. So as we can see, ParaView is able to understand very well that a number of files belong to the same group. So here we have the electrons being sampled at different moments in time, but from the structure of the file and from the name of the file itself, ParaView understands that they belong to the same class. They are the same particles, but they are, let's say, mapped through time. So we click on here, and just to show you, my file looks like this. So we have a number of fields and they are comma separated. So we will have to say that we don't have headers, but we have a comma that separates them. You could add any other symbol. You can add another symbol in here, or you can add any symbol that separates your field. A spreadsheet view is automatically created to show you the content of the file, but we're not interested in this. Now let's put a filter that is called table to points, and this filter is able to tell ParaView where to find the data it is looking for. So in this case, I'm telling you the X column is going to happen in field 1. This is field 0. This is the particle ID. X column, field 1. Y column, field 2. And Z column, field 3. Want to keep all data arrays, and we have 3D points, so we will not be ticking the 2D points. And here they are. We might also want to color them. So, for example, in red, right? So this is what we will see through time. I can also show you an animation. And here we see that it's just two-dimensional. But if I click on here, three-dimensional, and I zoom a little bit in, here it is. This is my flow through time. Now at this point, what I might want to do is add a pipe that is what contains my data. So it is in here, it's in sources cylinder. And for example, I can set a cylinder whose height is almost 1.1 and the radius is much smaller. So for example, say 0.03. And this will create my cylinder, which is in the opposite direction. And to do this, I will have to transform my cylinder, and I would like to say, for example, that is have to be translated of 0.55, and I will rotate it of 90 degrees. In here, in this case, it's going to be okay. You see, it is already displaying here the direction of the cylinder. And if I click on apply, then this is what is going to happen. Also, you see that it is not perfectly circular. This is because of the resolution. So we might want to, here is another important property. So we want to call the front face as to see what's inside. And then we will have to work on the resolution that I'm not finding now, but it is one of those properties that you want to take into account. It might be a property of the cylinder, actually. Resolution, here it is. So you'll see that it becomes almost circular once you apply, or always remember to apply. And this is where you see it. Of course, you might want to import more data. So let's say open H2+. There are other particles in here. They have the same properties. Another spreadsheet view is created. I might want to also add the axis grid, but it's not something I'm interested in now. I will have to add a table to points filter. and I will have to specify the same properties as before because the structure of the file is almost the same, and apply it, but I want to add a different color, so H2 plus is going to be blue for me. And I might also want to clip it. So what I want to say is I want a scalar. I want to remove those points I have before the 0 axis. So remember, x-axis was field 1. I'm going to clip it like this. And here's what I will see. And as a default, it probably is going to color mapping. You see there's a color map in here. I want to remove that. And I want to keep a solid color. And I want to keep it blue. Okay. And also, I might want to import. So if you click on here, you're going to be showing just the H2 plus. And if the I becomes bold, then you're showing the electrons as well. And let's open the protons. We will do something very similar. So we don't have headers. We will apply. We just close the spreadsheet view. We apply a table to points filter. We want to keep all data arrays. We want to apply this, and again we want to apply a clip. We want to clip it by scalars on a field 1 and by 0. And we click on apply. And finally, I will want to modify the color in here. So the color will be a solid color, and because they're protons, we will be having them in green. And what's important is that, okay, so what's important in here is that we remember that if we click on table to points, we will see something. We don't want to see this. We want to see only this. This is very important. So it hasn't applied our modification yet. Might because sometimes it does not update simultaneously. Okay, and oh sorry, it was field 3 because this is the z-axis, so happens here as well. So we are clipping it. Now to see the behavior in time, we can just start from the animation from 0, and we will see the motion. Or we can just modify the view and see it from here. See what is happening. You can just change views a number of times. So here I clipped it before. So the H2 plus was clipped. I clipped on the x-axis, but it might be more reasonable to clip it by z-axis. And here it is. So this is our final view. You can just stop the animation, and if we want to export the animation, we'll do just save animation, and that would be it. Save animation. Okay, I hope everything was clear. ParaView is very flexible and it can be used to really understand the data you have. So I would really suggest you to use ParaView to work on the output of your simulations and display the data you have to understand the physics phenomenon very well. Thank you for your attention.